Hey class, welcome back to Business Stats. This is 2.5, Module 2.5, Measures of Dispersion. In the PowerPoint slides and in the Learn Smart and all of the other resources that you've probably looked at up to this point, the concepts that you're covering are, or that you would have covered, are the concept, the definition of dispersion or variation, the definition of a range. You may have seen something about mean absolute deviation. The mean absolute deviation you do not have to worry about. You're not going to get tested on that. It's a deviation that is not really used a lot. The more popular ones are going to be the ones that we look to utilize in this course, and those popular ones are variance and standard deviation. Okay, and you should have also had a definition of population variance and population standard deviation, and then also a definition of the coefficient of variation, and then you should be able to calculate variation and standard deviation. So today we're going to do, in this video we're going to be doing an example of calculating some of those things. Okay, so right here we have a data set. I'm going to go ahead and read off this problem. We'll get started. The following are the number of summer jobs a sample of 6 students applied for. Find the range, sample variance, sample standard deviation, and the coefficient of variation. Okay, so let's start with the range first. The range is the easiest. So range, get my pen ready. The range is simply the maximum minus the minimum. Okay, so the range is just going to be the maximum, which is 23, minus the minimum, which is 7. So now that range is going to be 16. Okay, so that was the range, and so now let's start our calculation for our variance. Okay, so our sample variance. So this is a sample, so we have to use the formula for sample variance, which is slightly different than the one for population variance. Okay, so our formula for sample variance, bear with me, is going to be S squared is equal to sigma I equal 1 all the way to n of x sub I minus x bar squared, the whole thing squared, all over n minus 1. Okay, so the first thing is we got to figure out what are some of these variables in here. What are some of these unknowns? So what is n? N is the number of data elements that we have, the number of pieces of data. So we have 6 pieces of data here. So we know n is equal to 6. So we just kind of put that off to the side. That's that. And now we need to figure out, well, how are we going to deal with this whole sigma thing? And then furthermore, do we know everything that's in here yet? Okay, we know what I kind of stands for. I kind of stands for the iteration. N, we just figured out n is 6. That's the number of data pieces we have. And so then x sub I is going to be just whichever data point we're working with. Okay, n minus 1 is going to be our 6 minus 1, so that's a 5. But what is x bar? X bar is the sample mean. Okay, x bar is equal to the sample mean. So we have to find the sample mean first. So the formula for sample mean is just the average, right? That's just what we covered in the last video. It's just average. So we could go into a sigma formula, or we could just write it in kind of the layperson's way. Okay, and that's just adding up all the terms and then dividing by the number of terms. Number of data points, I should say. And those are not straight lines, are they? So anyways, so these add up to 84. And that's divided by 6. And so then that is 14. Okay? So that's that. So now we know what x bar is. So now we can kind of expand this formula out. So this is just saying the summation from of every x sub I minus the mean. So it's just, and then you're squaring that. And so you're summing up all of the squared deviations from the mean. So you'll see what I mean here in a second. Okay? So the first x sub I that we're going to look at is 17, because that's the first data point. Then you're going to minus off the mean of 14. You put that in parentheses and square it. And then because of the nature of the summation, we're just summing this the whole time. So then we do it again. The next data point. Minus the mean, that thing squared. Next data point. Minus the mean, that squared. So on and so on. We're just adding all of these up. Am I going to run out of paper? Nope, we are good, I think. Okay, cool. And this whole thing is over n minus 1, or 6 minus 1. Whoops, let's see. That's supposed to be a straight line. 6 minus 1, so we'll just say that it's 5. All right. So now we have 3 squared. So 17 minus 14 is 3. So that's 3 squared, so 9. 15 minus 14 is 1. 1 squared, or 1. 23 minus 14 is 9. So 9 squared, 81. 7 minus 14 is negative 7. Negative 7 squared is a positive 49. 9 minus 14, looks like I wrote 114 there, but that is in fact 14. So 9 minus 14 is negative 5 squared, and that's 25. And then 13 minus 14 is a negative 1, and a negative 1 squared is a positive 1. So we get all positive numbers here. And these are all over 5. Sorry for the chicken scratches here, guys. And then, so what we end up getting is 166 over 5, which is 33.2 jobs. So that's our variance, okay? And then the formula for our sample standard deviation, so our sample variance, which is called S squared, is 33.2, okay, 33.2 jobs. And the formula to get sample standard deviation is just to take the square root of that. So we'll say the square root of S squared is just going to be S, okay? So it's going to be the square root of 33.2, and that equals roughly 5.76 jobs. So this was jobs squared, I should say. So we don't really need to worry about the units. Generally, we're just going to refer to those as numbers. Okay, and then we scroll down, and then the last thing that it asks for is the coefficient of variation, which this is just a way of kind of measuring it as a percentage of the mean, measuring the standard deviation as a percentage of the mean. So the coefficient of variation, the CV, is just equal to the standard deviation divided by the mean times 100%. Okay, and so we have 5.76, which is our standard deviation, divided by the mean of 14. And then we say times that by 100%. And that's going to give us 41.14%. So that's so the coefficient of variation just says, okay, our standard deviation is roughly 41% the size of the mean. Okay, so it just gives you the standard deviation relative to the size of the mean. And that's that, guys. Measures of dispersion. Okay. Yeah, let me know if you have any questions. Be happy to answer any questions you guys have. Shoot them via email, or go ahead and put them on the discussion board under the Module 2 section. Be as specific as possible, and I'll get them answered for you. But yeah, all right, thanks so much for tuning in.